jump into data types. Okay, so data is nothing but processed information, and it has certain set of types which are listed on your screen: character, varchar 2, integer, decimal, date, timestamp, C log, D log, and B file. We're going to see one by one, and then we are going to explore what it stands for. Data types are nothing but, if you have a table, like a table is having 3 columns. Okay, you start entering data as it is. Like if I want to give a number for the first column, and the next person who enters the data, she wanted to enter some alphabets in the first column. So we can't load the tables like that. It will be clumsier, like it doesn't look good, and it will not be in ordered way. What happens if it is not organized is that when you try to retrieve data from the database is supposed to store data, and whenever we ask a query or whenever we query it, it is supposed to give us the result set. Right? So what happens here, when you try to load data in an unorganized way, scattered way, then we can't get the data. It will make it almost impossible to get the data what we actually want. It is going to make it difficult. So what we do is we define these columns are supposed to have these type of data only. Like that, we are going to put some restriction. The basic level of restriction to enter data inside a table, to store data inside a table, is nothing but data types. Okay, so let's start with character versus varchar 2. And we are going to learn with the example. So in the center, you are seeing one table. Yeah. So I have given a column name. The same column, I have defined it as character length of 5, and the next one is varchar 2 length of 5. If a column name is going to get defined as character data type with the length as 5, and the same column is, if it is defined as a varchar 2 data type having the length of 5, what kind of difference would it make? Let's learn both character versus varchar 2 and understand both the data types. Okay, so let's take the first example of this character length of 5. So the first data, what I enter is IND. Okay, IND. So when I enter it, would it accept? Yes, it would accept. Why am I telling that it would accept? Because the length of the word which I'm trying to enter, the data, is maximum length allowed in that particular column is 5. On both, whether it is character or varchar 2, maximum length is 5. So I have entered only 3, so it is going to allow, right? But what happens in the storage space is, if you define a column as a character type, okay, if you define a column as a character type, it is going to allocate 5 spaces. Though only 3 I and D is going to be entered, but it will allocate 5 spaces. What happens in varchar 2 is, it will allocate only 3 spaces, because according to the data, it will adjust. So to give a varchar 2 variable character. Okay, character is fixed length. Whatever the maximum length you have defined, it will allocate it. Even if it is less or more, it will be giving. More it cannot be done. If you're giving less number of characters also, it will allocate. No. I have been told that I have to give you 5 spaces, I'll give you. Whether you enter only 3 letters or 4 letters, it is up to you. But I will allocate you 5 spaces. But how does a varchar 2 speaks? Varchar 2 will ask, okay, how many spaces do you want? I need 3 spaces. Okay, please take it. Okay, so both the ways, IND, when you enter, it will accept. The way it stores is different. This will be a fixed length and this is variable length. Okay, by doing this, varchar 2, we are actually trying to save the spaces, right? Good. The second important thing is, the second record is India, INDIA. How many letters are there? 5 letters. Very good. So does it going to accept? Yes, because 5 is allowed maximum length. So it is going to accept our entry data. Okay. So when it is put up inside a name of character type, only alphabets are allowed. Okay, only alphabets are allowed inside a character type column. When it comes to varchar2, actually in India, INDIA, instead of I have replaced it and put up as 1. Okay, I have put up as 1. In this font, it is not different, but I have put 1 and D1A. What happened? Will it accept? Yes, it will accept. So varchar2 will accept alphabets, numbers, and symbols. Like if you want to enter, column with address are going to have a comma and then hyphen, right? The numbers NO and then 1, 2, 3, 4, some house number will be there. So it can be defined under varchar2, but it cannot be defined under character because obviously it is going to accept only the alphabets, not numbers or not symbols, only the alphabets. So this is the second difference. Okay. The third one, maximum length. Yes, both are 5. So if you're going to enter INDIAN, Indian, then obviously it is not going to allow you because it is having 6 letters. So maximum length is 5. The rules are same, whether it is a character type or a varchar2 type, rules are same. Maximum length 5, only 5 letters are allowed. When do you prefer a character and when do you prefer varchar2? Based on our learning, if you want to store only alphabets, then you choose character. If you want to store a number, symbol, and combination of alphabets, numbers, and symbols, then you choose varchar2. Again, the second criteria, the first point what we have seen is, if you have some idea about the data, for example, abbreviations and initials of a person will be maximum 1 or 2 or 3 letters, like 3 alphabets or 1 alphabet, right? It will never be more than 3. It is always the initials will be 1 or 2 only, maximum 3. It will never be more than 3. Or abbreviations, we'll try to stick on. For example, January, we put JAN. April, APR, June, JUN. So these are always going to stick up into 3 letters, right? And it is going to be alphabets? Yes. Those kind of columns you can choose character length of 5 or 4, whatever it is, put up for. Why am I proposing this? Because character will always allocate whatever the maximum length it has been allocated. By this way, always instead of 5, you have 3 letters, right? Maximum spaces will not be wasted. If you have no idea about the data, whether it can be short or big, so names. Okay, so we don't have an idea about how big the address would be. Few houses will have only 2 lines of address and few will be too big, right? So we don't have an idea about the address. So let's put up whether it is mixed up with numbers, alphabets, and symbols. Again, we don't have idea how big it is going to be. So we'll give a maximum length and we're going to put in varchar2 so that it will allocate as per the data. It will not waste the space. So you're being very efficient by defining a data type to a particular column. You're restricting the type of data like alphabets or numbers or something, and you're being efficient by choosing the type of data for a particular column so that the storage is also saved. Okay, these are the 2 things. So character and varchar2, you should be knowing the differences now. Moving on to the next. Let's talk about data type of numbers, integer, decimal, and numbers. Okay, so let's take an example of integer, only whole numbers as seen in the screen, 173226. Okay, this is a whole number, only whole numbers will be accepted in an integer. And the next one is decimal. Decimal is supposed to be represented with P, S, precision and scale. Okay, so scale is exactly considered, but precision is more or less. Okay, so what happens here is, what is a precision and what is a scale? Do you find that picture down 173,226.62? It is marked as P. Precision is nothing but the entire length of the number, including the decimal values, the entire length. So here the entire length is 8, comma, scale is what? 2. After the decimal point, how many digits do I have? That is called a scale. So precision is nothing but the entire total count, which is 8, and 2 is the scale, which is nothing but exactly how many digits do I have after the decimal point. So here 173,226.62 will be represented as decimal of 8, 2. Okay, decimal of 8, 2. So if you give a column of data type decimal of 8, 2, then when you enter this data 173,226.62, it will accept. Okay, the next one is number. Number is also to be given as precision comma scale again. So 8, 2, number 8, 2. So what is the difference between decimal and the number? Both are given as precision comma scale. There decimal 8, 2, here number 8, 2. The number is same. The same number I can enter if I give the data type as decimal or number. Yes. What is the difference is, in number, scale and precision are considered exactly as defined. But in decimal, it is not. Scale exactly, like after the decimal point, how many digits should you have? That will be exact. But precision is more or less. Even if you not have 8, if you have more than 8, like a 0 in the front and all, it will accept the value. Okay, so that is the difference between decimal and number. So now we have seen the number data types: integer, decimal, and number. Okay, the next one. Now we are going to see about data type, date and timestamp. Data type, date and timestamp. Date is only date, like it holds TD, date, MON, month, YYYY, 4 Ys, which is nothing but 1987, 2001, 2020, like 4 digits of year. So that is only date. When you go to timestamp, it has both date and time. The result set, like the format is given below. You give date 06 or 07 hyphen MON, the month June, JUN, or Jan, JAN, or April, APR, hyphen the year. Okay, give a space. HH is for hours, then colon minutes, then seconds and microseconds. So timestamp format is this. Okay, so this is once again a type of data which you can restrict to, where either you want to have only date inside a particular column, then you give a data type as date for that particular column. If you want to give data date and time, then you define that column as timestamp. Okay, so far we have seen whether character, or you define a column as varchar2 or integer, number, decimal, or date and timestamp. The last thing is CLOB versus BLOB versus B file. What are these things, CLOB, BLOB, and B file? CLOB is nothing but character large object. BLOB is binary large object, and B file is binary file. Okay, so character large objects, I have given an example of resume. Resume, yeah. So resume are like going to hold all the character values. It's a quite big text format, right? So binary large object, I have given an example as photo, means images. If you want a column to store a big text formats, then you define that particular column as CLOB. If you want a particular column to save the photos or images, then you define the column as BLOB. If you want a particular column to store files, whether it is audio or video files, then you define the column as B file. These are not usually done directly. You cannot directly give, enter the data, like you can't save the photo or files. So you will use a tool to actually store these kind of resume images and audio or video files inside a database. It can store, that is what I'm trying to say. It holds these kind of data types also. Oracle encourages these kind of data types, but you need a tool to do this kind of data entry. Otherwise, entering a number or a name or an address, you can directly do it using SQL developer tool. Okay. The next thing is constraints. The second topic, constraints. So we've already seen about the data type. Now what we're going to see is data constraints. So these are the 5 important data constraints: primary key, foreign key, unique key, not null, and check. We'll see one by one. These are very important because data types are going to express what kind of data you're going to populate inside that particular column. Okay, so what kind of data are you going to load inside a particular column is decided by the data type. What data, right data or a valid data is getting entered inside a particular column or not, this constraints will check that. Okay, what kind of data, whether it is a valid data is getting entered inside the particular column, constraints will check. So data type we have finished. Now going forward with constraint, let's learn first about primary key. So primary key, now there are 4 points which you have to remember about primary key. If you have a table, only one column can be defined as primary key. Means that is the main column for that entire table. Okay, so only one column can be defined as a primary key. That is a key column. That is an important column. Like that, you will tell that. Okay, and the next one is no duplicates are allowed, because you say that is an important column in the table, and you cannot allow duplicates inside it. If it has duplicates, it doesn't make sense. So when you define a particular column of a table as a primary key, it should not hold any duplicate, it should not allow any null values, and it should be auto indexed. Means it will be automatically indexed. We saw this concept of indexing. Indexing is to fast retrieval of data, right? Indexing is fast retrieval of data. So primary key, you're marking it as important column, right? In a table, you're marking the particular column as a primary key, means you're marking that column as important column. Means automatically it will be indexed. Indexing is nothing but marking it as important, so that whenever there is some query with related to this primary key, fatafat it will give the result to you. So there are 4 important points. Only one column is allowed to be a primary key in the table, and no duplicates are allowed, no null values are allowed, and automatically it will mark that column as an important, auto indexed. So next thing is unique key. Again here, not just one, you can have any number of columns as unique key in a table. If a table has 4 or 5 columns, out of the 3 columns I want to make those as a unique key, means unique key columns, I can do that. It will allow. Okay, but here what is the matter is, it should not allow duplicates, but it will allow null values. Okay, you can enter any data inside unique key column. If you are defining on one particular column as unique key column, you can do an entry. Okay, you can do an entry. You cannot have a duplicate entry. So if you put 1 for the first record, the second record should have 2 or 3 or some other number, not again 1, because it will never allow duplicate. By name itself it says unique values, right? So no duplicates are allowed. But if I don't want to put any data inside, if you want, you can leave it as blank. You cannot allow duplicates, but you can leave it as blank. Now this is also auto indexed because there is no duplicate. Yes, I can use this also as an important column. Yes, so this is also auto indexed. So the next one is foreign key. What is a foreign key? Again, foreign key in a table, can we have more than one column defined as a foreign key? Yes. In a table, if it has 20 columns, 5 columns are foreign key columns, reference columns. What do you call as foreign key is reference column. So can we have like that? Yes, we do have. So duplicates are allowed? Yes, duplicates are allowed. Null values are allowed? Yes, null values are allowed. What is this? It is allowing duplicates, it is allowing null values. So why do you say then this is a constraint now? Yes, this is nothing but a reference value. What do you mean by reference value? What do you mean by foreign key? For example, let's say we are Indians. Why? I am a native of India. My native is India. So when I stay here in India, I'll be called as Indian. I'll be called as a native person. But if I am going to travel from this country to another country, there they will be referring me as a foreign person because I'm not of that native, right? So that's the reason why other country people visit India, we refer them as foreigners, right? So those people are citizens of some other country, they visit our country, so that's why we say them, we refer them as foreigners. So when we travel from our place to another country, okay, so we will also be stated as foreigners. Same way, foreign key is nothing but it is a reference key of the primary key. What do you mean by reference of the primary key? Say, for example, in a table, you have only one column as primary key. Okay, and this particular column's data has to be referred somewhere else in another table, referenced inside another table. Okay, so then that particular column in the other table will be called as foreign key. In this table, it is a primary key, but it is a referenced inside another table, so it becomes a foreign key. I'm here as a native, so I'm an Indian, so I am a native person. If I travel to another country, I become a foreigner. Okay, so data which is present inside the primary key column in this table, it is called as a primary key value, primary data. And when it is a reference to some other table, then it becomes a foreign data, foreign key reference data. Okay, so that is called as primary key, foreign key relationship. So the next one is not null. Okay, not null by name itself, you would understand no null values. Okay, no null values. Okay, so null values, no, not null columns also can be number of, yes, in a particular table, if you have hundreds of columns, I want some 80 columns to be not null. I want mandatorily, I need some data, but no null values. Okay, so when you fill in the website, there will be this asterisk mark. Next to name, next to date of birth, there will be asterisk mark. Means those are mandatory fields to be filled in. You cannot leave it blank. Same way, not null columns are not supposed to be left out as blank. They are not supposed to be having any null values. They are demanding for a data to be entered. So columns which are referred as not null constraint, they are expecting some value. Those are mandatory columns to be filled in. Okay, so that's why they say that duplicate values are allowed. You can enter any duplicate values, but no null values, which is exactly opposite to unique key, right? There are no duplicates. Null values are allowed. Here, duplicates are allowed, but no null values. You cannot leave it as blank. You have to give some data inside that particular column, but you should not leave it as blank. Okay. So the next one, check constraint. For example, in a column, you want to restrict the data to be above 10,000 or something in a numeric value. Okay, so if you have a specific condition to be applied on that particular column, then you go for check. Check constraints are nothing but if you have a particular condition to be applied, then you can go for check. So this is all about this thing, constraints. Let's have a summary about it. So the attributes are number of columns, duplicates, null values, and indexing. So for a primary key, only one column. will be allowed as a primary key. Unique key, not null, foreign key and all can be applied more than one number of columns. Again, for a primary key, will it allow duplicates? No. Unique key allows duplicate? No. Not null? Yes. Foreign key also will allow duplicate. Null values. Primary key will not allow any null values. Unique key will allow and not null will not allow, and foreign key will allow again. So indexing, it happens only for primary key and unique key. Not null and foreign key will not get auto indexed. Okay, manually you can do the indexing. Okay, that we'll learn later. But automatically, these are the two types of constraints which will create index. Auto indexed will be happening if you define a column as a primary key or a unique key. Automatically, that particular column will get indexed. So this is a summary about the constraints. So we have learned about data type and constraints in this session. So this is all about the introduction to data. So thank you.